This is an experiment to determine the charge to mass ratio of the electron. What you're looking at here is a cathode ray tube where electrons are thermionically emitted from a cathode, and they're accelerated through a large voltage to the anode, where they then enter this glass jar that has argon gas in it, and they will travel in a circular path because they will be immersed in a magnetic field. The magnetic field comes from these coils of wire, and this configuration is called a Helmholtz coil because the radius of the coils is equal to their separation, and that creates a nice strong magnetic field right through the center of the coils. When the electrons enter the argon gas and travel in their circular path, you will see a green beam inside the glass tube. Now, you're not actually seeing the electrons. What you're seeing is the light emitted by the argon gas atoms when the electrons that come from the anode collide with the electrons in the argon gas. Those electrons are knocked off, and when the argon gas then goes to grab those electrons back, light is emitted, and that's the light you're seeing. But it is essentially in the path of the electrons. So the variables that you'll be looking at will be the radius of the path of the electrons, and the way you measure that is by this little glass rod that runs right through the center of the tube, and it is calibrated with little etchings for the 5, 6, 7, 8, 9, 10, 11 centimeter marks. The other variable that you'll be looking at will be the current in these Helmholtz coils, and that current is directly proportional to the magnetic field, and the magnetic field is what determines how tightly the electrons travel in a circular path. So I'll have to turn the lights off, and then we'll see this green beam.